So good day to each and everyone. This is Joanna May Paracolias, the group leader of Precocity Unite. So Precocity describes the smartness or the advanced skills achieved by such person, and we chose this team name because we believe that this person behind Precocity Unite has the smartness and the skills that best describes our team. So again, I am Joanna May Parcolias, and I am the group leader. So in this report, we are going to discuss about the chapter 7, which is project management, and chapter 8, the modern trends in manufacturing. So chapter 7, project management. So when we say project, it is an interrelated set of activities that has a definite starting and the ending point, which results for a better and successful unique product, which that means that projects are not repetitive, and we have listed 10 examples of an activity that has a starting and ending point. First is constructing a bridge, dams, highway, or even buildings. Next is producing an airplane, missiles, and some large machines. Third, introducing a new product. Fourth, installing a large computer system. Fifth is redesigning the layout of plant or such office. Sixth, construction of a ship. Seventh, fabrication of a steam boiler. Eighth, maintenance of major equipments or plants. Ninth is commissioning of a power plant or factory. And lastly, number 10 is conducting a national election, just like what happened last May 9, 2022. Next, basic steps in project management. Managing a project, regardless of its size and complexity, requires identifying every activity to be undertaken and, of course, planning when each activity must given the beginning and the ending, only in order for it to be completed that describes the overall project on time. And typically, all projects involves 6 steps. First is you have to describe what project it is, followed by you have to develop a network model. Third, insert time estimates. Of course, in order for you to have a successful project, you have to estimate how much time would it take to have the project end successfully. Fourth, you have to analyze the model. Fifth is you have also to develop a project plan. And lastly, number 6, which periodically assess the program of the project, and you just have to repeat the steps 2 to number 6, only if needed, of course. Next is network. A network is a graphical representation of the project activities arranged in a logical sequence and, of course, depicting all the interrelationships among them. So here are the terminologies used in network diagram. Number 1, activity. So when we say activity, it means that a work or a job. And also it has been a very time consuming because it has the so-called process. And also it is represented by an arrow of the network diagram or the AOA system, which means activity on our network. So we have here the numbers 1, 2, 3, and 4, ABCs, and such events. Also, AON means activity on node. Next, number 2, event. An event is a specific instant of time that marks the start and end of every activity. Second is the critical path. It is a sequence of activities that decides the total project duration. Fourth, duration. So duration is the estimated or the actual time only required for you to complete a task or an activity. Fifth is total project time. It is the time for you to complete the project, or in other words, it is the duration of the critical path. As what I have mentioned on number 3, critical path, it is a sequence of activities that decides the total project duration. Next, earliest start time. It is the earliest possible time at which an activity can start, and also it is calculated only by moving from the first to the last event in the network diagram. 7, if we have the earliest start time on number 6, we have latest start time on number 7. And it is the latest possible time by which an activity can start. Number 8, earliest finish time. It is the last event time of the head event. Also, it is calculated by moving backwards in the network diagram. 9 is latest finished time. It is the last event time of the head event. Of course, it is calculated by moving backward in the network diagram. Just like the number 8, earliest finish time. Next, number 10, float or slack. When we say slack, it is with reference to an event, and when we say float, it is with reference to an activity. So there is a difference between an event and an activity. Number 11 is free float, or should we say latest finish time to earliest start time. And the free float is the activity duration. So we have here the rules for network construction. We have 13 primary needs or rules and completing network construction. So the following are the following are the primary needs for constructing an activity on R or AOA network diagram. First, you have to analyze the start event and the ending event of an activity. When we say starting event, it is the tail, and the head event is the ending activity. Number 2, the network should have a unique starting node or tail event. Okay. Number 3, the network should have a unique completion node. When we say completion node means it is the head event. Fourth, no activity should be represented by more than one AOA in the network. Next, number 5, no two activities should have the same starting node and the same ending node. Of course, each activities should have different starting and ending node for us to compare. And number 6, dummy activity is an imaginary activity, which indicates precedence and relationship only. And of course, the duration of a dummy activity is 0, since it is just an imaginary activity. Next, number 7, the length of the arrow bears no relationship to the activity time, just like what does the diagram shows from the previous slide. 8, the arrow is the network identifies the logical condition of independence. 9, the direction of arrow indicates the direction of the workflow. Next, number 10, all networks are constructed logically or based on the principle of dependence. Number 11, no event can be reached in a project before the completion of the president's activity. So as what I have said earlier, that each and every activity, event have its estimated time finished, so that it is in order for us to think that each event should end this time, this activity should end this time, and we have to follow that in order for us a very successful and unique outcome of every event or every activity that we are doing. Next, number 12, every activity in the network should be completed to reach the objective. Next, we have number 13, no set of activities should form a circular loop. So again, number 12, every activity in the network should be completed to reach the objective. And number 13, no set of activities should form a circular loop. So this is a time estimation of an activity. If T and the small letter O below means optimistic time, and for example, time estimate for a fast activity completion. Next is TP, pessimistic time, or the maximum time duration of an activity can take. Next, TM, or most likely time. And lastly is TE, the expected time of the activity, and it has its formula that open for parenthesis, TO plus 4, TM plus TP, close parenthesis, divided by 6. And of course, it shows the formula for the variance of an activity time, and we have network scheduling. So the biggest advance in project scheduling since the development of the Gantt chart in 1917 was made between 1956 to 1958. During this period, two new scheduling techniques were developed, and these techniques are, first, we have the Program Evaluation and Review Technique, or also known as PERT or PERT. And second is the Critical Path Method, or the CPM. So both are based on the use of network or graphical model to depict the network, or the work task being scheduled. So the popular of network-based scheduling can be attributed to its many benefits, especially to ease of use. And other benefits includes the following. First, we have to provide, it provides a visual display of needed tasks and their temporal ordering, in which makes it easy to see how tasks should be sequenced, or for example, this table below. That's it. And this assists communication and cooperation among task teams because each team can see how it works affects the other team. Number 2, it provides a relative accurate estimate of time required to complete the project of the proposed resource level. Number 3, it identified and highlights the tasks that are critical to keep the project on schedule. And number 4, it identified and highlights the tasks that are critical to keep the project on schedule. Number 4, it provides a method for evaluating the time cost trade-offs resulting from reallocating resources among the tasks. Number 5, it provides a method for monitoring the project throughout its life cycle as the project progresses. PERT or CPM easily identifies change in which tasks are critical and how the expected completion date is affected. Number 6, it approves a convenient method for incorporating uncertainty regarding task times into the schedule, and of course, it happens to evaluate the effect of this uncertainty on project completion time. So we have to proceed now to the next reporter. Thank you.
Hello everyone, my name is Stefano Ryan Espina, and today I will be talking about the difference between PERT and CPM. So first of all, what is PERT? PERT is a probabilistic model with uncertainty in activity duration. Activity duration is calculated from T0, TP, and TM. It is an event-oriented approach. Also, PERT technology uses a word like network diagram, event, and slack. The use of dummy activity is required for representing the proper sequencing. PERT basically does not demarcate between critical and non-critical activities. PERT is applied in projects where resources are always made available. PERT is suitable in defense project and R&D where activity time can't be readily predicted. Now let's talk about CPM. CPM is a deterministic model with well-known activity duration. It is an activity-oriented approach. CPM also CPM terminology employs words like arrow diagram, nodes, and float. No dummy activity required. CPM marks the critical activities. CPM is applied to projects where minimum overall cost is the prime importance. And lastly, suitable for plant maintenance, civil construction projects, etc., where activity duration is known. Now, let's talk about the steps in using network techniques. First of all, plan project. First A, the project is analyzed by determining all the individual activities, sometimes called tasks, jobs, operations, that must be performed to complete it. Another one, B, a planned sequence of these activities are shown on a network. A graph where our arrow and circles represent the relationship among project activities. Second one is the schedule of the project. Uh, how long will how long it will take to perform each activity is estimated. In order to locate the critical path, the calculation is performed the longest time chain of sequential activities which determines the duration of the project. This also this step also provides other information that is useful in scheduling. The above information are used to develop a more economical and efficient schedule. Another one is project monitoring. The plan and schedule started above are used to monitor the progress. Throughout the execution of the project, the schedule is revised and updated so that the schedule represents the current plan and status of progress. Per critical path, most likely time estimates. Thank you.
Good morning, everyone. I am Rajisa Ayayuga Gomez, and I am the next reporter from the group. And I am going to show you some examples. I am going to show you charts and diagrams. So to begin, the above points can be explained with the following examples. Example 1, a project consists of the following activities and time estimates. Here we can see in the chart the activity, least time in days, greatest time in days, and the most likely time in days. In this one, the activity is something that is means work or job. It is a time-consuming process. It is represented by an arrow in the network diagram. So I am going to show you what diagram I am talking about. This is the solution. The network diagram is shown below. This is the diagram I am talking about. We have this diagram is called a network diagram, and we have two types of network diagram, which is the AOA system or the activity on arc network, and the other one is the activity on node or AON. So, and this is the formula for the expected task time. expected task time is equals to optimistic time plus 4 plus most likely time plus pessimistic time divided by 6. And by using this formula, expected task time for different activities are shown below. This one, which we have combined the chart one and the network diagram one. So from the above figure, number 1, 4, and 7 is the critical path. And therefore, I conclude that the project duration is 25 days, which is the sum for 14 plus 11. And that would be all. Thank you.
Hello guys, I am Mokim Adrian G. Gloriani and today I'm going to discuss project management techniques. There are two types of resource problem or analysis, namely resource smoothing and the resource leveling. Resource smoothing is used when the time constraints takes priority, meaning that when there is a time frame or time pressure, it has to get the most priority. That's when resource smoothing is being used. There may be a ceiling on the availability of resources in a particular period of time, meaning there may be a limit to the amount of resources available at any given time. For example, only RS-125 LAKH. And by the way, it is a type of motor vehicle in India. So only RS-125 LAKH may be available per year, and of those were unutilized or if that amount not used during 1 year. The remaining amount of lapses. In this type of case, a resource analysis used for this is called resource smoothing. It's a project management technique that involves resolving overallocation or scheduling conflicts to ensure a project can be completed with the available resources. Resources includes the time, materials, or tools needed to complete a project. The objective is to complete the work by the required date while avoiding peaks and troughs of resource demand. Resource leveling, on the other hand, is used when the availability of resources is paramount, meaning the availability of resources are more important than anything else. Resource leveling is a project management technique that involves resolving overallocation or scheduling conflicts to ensure a project can be completed with the available resources. Resources includes the time, materials, or tools needed to complete the project. From this figure, it is observed that the peak manpower requirement is 21 and it occurs from 0 to 6 weeks. The activities which are scheduled during the period are 1-2, 1-3, and 1-4. The activity 1-2 is critical activity, so it should not be disturbed. Between activity 1-3 and 1-4, the activity 1-3 has high slack value of 6 weeks, whereas it's only 4 weeks for 1-4. Hence, it can be started at the end of 6 weeks. The corresponding modification is shown by the following histogram. As a result, the manpower requirement is now consistent throughout the project's duration using the resource leveling project management techniques. So that's it, guys. Thank you for listening. The next reporter, please.
Good day, everyone. I am Shirley Junaparacha, and I'll be discussing the basic concepts of CAD under Chapter 8, Modern Trends in Manufacturing. But first, let me introduce to you what is CAD. CAD, or Computer-Aided Design, is a software frequently used by engineers, architects, and designers. Its purpose is to increase productivity, improve the quality of design, improve communications through documentation, and helps us create a database for manufacturing. CAD involves the 5 uses of computers, which are creating, analyzing, modifying, optimizing, drafting, or documenting. The figure you see below is the 4 phases of CAD. First, you create a geometric model. Geometric model is a mathematical technique that is done by using a simulation software. Next, it will be analyzed to know what kind of design condition you like to identify opportunities for optimization. After analyzation is optimization, which helps us maximize spaces in resources. Also, it helps us reduce errors. And the last step is drafting and documentation. CAD tools includes the following 3 elements. First element is computer modeling and computer graphics. Geometric modeling and computer graphics helps to generate and visualize models on which the analysis is done subsequently. Modeling and designing are being used as synonyms nowadays. The kind of analysis which can be done on a model is controlled by the type of model used. Hence, the computer-aided model must be made only after confirming the kind of analysis which is to be performed on the model. In short, one of the main tasks of computer graphics is the construction of models of scenes from the physical world and their visualization images. This task is important, especially in geometric modeling. Geometric modeling aims to create complete information representation of 3D real objects, which allow us to calculate any well-defined geometric property of the object. Second element is analysis and optimization tools. These are the algorithms and programs for exclusive application which are applied onto the virtual product already modeled. This section can predict the behavior of the model under the loading condition when all constraints are simulated using boundary conditions. The analysis process is iterated number of times with varying attributes to optimize the results. The results so obtained from the model can be anticipated from the behavior of actual model in real situations. In short, optimization is concerned with the analysis and algorithm aspects of maximizing or minimizing an objective function subject to constraints, often in complex problems in high dimension. The third and last element is drafting and documentation. The model was already created, analyzed, and optimized, guarantees a safe model under real conditions. This safe model drawing is to be communicated to the production floor with technical illustrations. The tool used for this application is called computer-aided drafting, or called computer-aided design and drafting, computer-aided modeling or designing, and computer-aided drafting represents 2 different concepts. So, in this element, the model was finally created, analyzed, and optimized, and was ensured that it is safe in real conditions. This model will be passed on the production floor with technical illustration. There are 2 tools used to complete this application, which is computer-aided modeling or designing and computer-aided drafting. The differences of the 2 concepts will be discussed by the next presenter.
Good day, everyone. I am Muslima Dipatu Angimpao, and I will be tackling about the difference between computer-aided modeling or designing and computer-aided drafting. So first, computer-aided modeling or designing, this is done before analysis is performed on the geometric model, while in computer-aided drafting, it is done after analysis is performed on the geometric model. Second, computer-aided modeling or designing, it provides dimension which may or may not be safe, while in computer-aided drafting, the dimensions are safe since these are obtained after the analysis. In computer-aided modeling, it is 2D drawing or 3D model, while in computer-aided drafting, this is generally 2D drawing. Lastly, in computer-aided modeling or designing, it is a model is used for design analysis, while in computer-aided drafting, these are made basically for conveying the production design. So next. CAM, or computer-aided manufacturing, is described as the direct or indirect use of computer in the planning, manufacturing, inspecting, and regulating of manufacturing operations. CAM operations include those which manufacture the product using the product drawing and technical illustration as input from the CAD, and then inspect and package the product for shipment. So as you can see in our presentation, it showcases the various phases of CAM section for you to have a better understanding of it. So first, geometric, next, process planning, next, NC part programming, and then machining, inspection, and packaging. So in CAM, the basic information required is actually geometrical information, which is supplied to the CAM process through the CAD model already generated and analyzed. Interface algorithm extract that necessary geometrical information from the CAD model and feed it for process planning, part programming, machining, inspection, and packaging, just like what I have mentioned earlier. So these are the three elements for CAM tool. First, CAD tool. Second, manufacturing tool. Third, networking tools. In CAD tool, the geometric model developed during the CAD phase of the product cycle is used to extract the model's basic geometric information. To implement in the manufacturing tool, which is the next CAM tool, relevant information such as the shape, contour, and sizes is extracted from the model. Next is manufacturing tool. The manufacturing tool is defined by the fundamentals of the production process. It specifies the technique or method by which the product can be manufactured. This covers part of programming and manufacturing, as well as computer-assisted process planning or CAPP, and tool and cutter design, and etc. Lastly, networking tools. For communication between various machines and computers, knowledge of network and interfaces is essential. A communication for or networking tool is required for CAM to function successfully. For example, transferring a part from one computer to 4 distinct machines, or operating a robot from a computer.
Hello everyone, I am Roblin Maybe Ermac. So for today, I will be talking about Commonplace Computers First Year 2 Basic Purposes. First is computer monitoring and control. Where computers are used to control and monitor the applications, the major applications included in this category are controlling machines and robots. So the monitoring system seek to observe and record data. On the other hand, the control system seek to actively maintain or change the state of a system through the use of actuator. So when we talk about actuator, it is a device that produces motion by converting energy and signals going into the system. So an actuator can cause a machine to operate. Letter B is manufacturing support applications. It includes those applications that are not controlled directly by computer, but are used to support the primary and direct operations. So such applications include numeric part programming. The CAPP are also known as computer-aided process planning, generating computer-aided schedules, and all other kinds of planning. Letter C is flexible manufacturing system, or FMS. A FMS integrates all major elements of manufacturing into a highly automated system. FMS has born in the latter half of 1960s as a means to improve productivity of small and medium volume production. So it is a production method that is designed to easily adapt to changes in the type and quantity of the product that is being manufactured. Machines and computerized systems can be configured to manufacture a variety of parts and handle changing levels of productions. So a flexible manufacturing system can improve efficiency and thus lower a company's production costs. So this is the structure of the FMS, or also known as flexible manufacturing system. The one with blue line, it is the information, and the bold double arrow, it is the material flow. First is the system controller, down to loading and unloading. to work transportation, to machine tools automated, to material handling, to tool room storage, and lastly, the auxiliary equipment. So the major components are, letter A is automated machine tools. In order to achieve the system flexibility, computer-controlled general-purpose machine tools are normally used. So machine tool automation increases utilization and throughput time and lower cycle time and labor costs. Automation also helps to maintain parts quality and consistency. Letter B is work transportation device. These devices are used to carry parts between loading area and machining station. Individual conveyors are used for high degree of flexibility. So it is a device or structure that is human powered or motor powered, and that is used to carry person or things from one place to another. Letter C is material handling device. This device transport work in process or tools to assigned positions. So it involves short distance movement within the confines of a building or between a building and a transportation vehicle. Letter D is loading and unloading station. The raw materials and their finished parts are loaded or unloaded in this area by the robot. So loading and unloading means the process of getting goods in and out. Letter E is tool room and storage. All the tools used in the system are stored in the tool room and transported to machining centers when required. So tool rooms are the nerve center of many manufacturing operations. Tool rooms often needed to store a myriad of items from small to very large, and they need to be easy to find and retrieve when it is needed. Letter F is auxiliary equipment. Beside machine tools, an FMS can also include cleaning, online inspections, automated measurement, and gauging equipment. So it is a peripheral equipment that may be an integral part of the extrusion process to improve or optimize the extrusion process, efficiency, and ease of operation. And lastly is the system controller. The system controller oversees the operation of an entire FMS. It coordinates the operation of a variety of equipment in the system. So a system controller, it manages and commands, directs or regulates the behavior of other devices or system using the use of control loops. So let's go on to the advantages of flexible manufacturing system. So number one is, there is a greater potential to make changes in terms of product technology. Second, it reduces both direct and indirect labor costs because of automatic handling, gauging, and inspection facilities. Third is, it provides reduced manufacturing lead time, reduced inventory of parts, both stock and work in progress. Fourth, it improves the utilization of equipment. In this case, utilization is 85% compared to 50% in conventional method. Fifth is, it provides a better management controlled by integration of computer. And lastly, it provides better and more consistent products. So some of the advantages of an FMS associated with flexible manufacturing system. It includes reduced manufacturing costs, increased labor productivity, increased machine efficiency, improved product quality, increased system reliability, reduces parts inventory, shorter lead times, and increased production rate. So last is the computer integrated manufacturing, or also known as CIM. So CIM is defined as process of integration of CAD. So when we talk about CAD, it is computer aided design. CIM is a computer aided manufacturing and business aspect of a factory, and it attempts to describe complete automation with all processes functioning under computer control. CIM includes management information system, sales marketing, finance, database management system, design, manufacturing, and control and barcode software, which helps to manage and control the overall factory environment. CAD, CAM, and CIM basically involve fundamental principles of these underlying branches with hardware and software to operate and utilize them effectively. So CIM is the use of computer-controlled machineries and automation system in manufacturing products. CIM combines various technologies like CAD, or also known as computer-aided design, and the CAM are also known as computer-aided manufacturing, to provide an error-free manufacturing process that reduces manual labor and automates repetitive tasks.
Good day, everyone. I am Mariel
Mayap.
Mayap. Good day, everyone. I am Mariel Mayap, and today I am going to discuss the JIT, or the just-in-time, and their objectives. So first of all, what is just-in-time? It originally referred to a production of goods to meet customers' demand exactly in time, quality, and quantity, whether the customer is the final purchaser or the product or another process further along the production line. So just in time. The just-in-time production concept was first implemented in Japan around the 1970s to eliminate the waste of materials, machines, capital, manpower, inventory waste. When first developed in Japan in the 1970s, the idea of just-in-time, or JIT, marked a radical new approach to the manufacturing process. It cut waste by supplying parts only and when the process requires them. So throughout the manufacturing system, the JIT concept has the following objectives. First is receive supplies just in time to be used. So the just-in-time, or JIT, is a purchasing and inventory control method in which materials are obtained just in time for production, to provide finished goods just in time for sale or just in time to be used. Second objectives is produce parts just in time to be made in a sub-assembly. So sub-assembly is a process by which related components are assembled into a part for future use in a assembly of the final product. Next is the produce sub-assemblies just in time to be assembled into a finished products. So these components are assembled into a part used in assembly for finished products. And last is produce and deliver finished product just in time to be sold. So the main objective of this method is to reduce inventory holding costs and increase inventory turnover. Next slide. So in order to achieve these objectives, every point in the organization where buffer stocks normally occur is identified. Then critical examination of reasons for such stocks are made. A set of possible reasons for maintaining a stock is listed below. Number one is unreliable and unpredictable deliveries. Second is poor qualities from suppliers. So suppliers build their reputation on the quality of the goods or materials they provided. If the quality is not good, the production is not good. Poor supplier performance leads to directly to operational delays, or delays can lead to missed or late orders. Next is increased variety of materials. So materials offering a distinctive characteristic factors in improving product. Next is machine breakdown. Machine breakdown can cause delays in the production system. Due to these delays, work activities are completed later than the time planned. Next is labor absenteeism. Absenteeism can affect individual productivity. Simply put, if someone works less, they are likely to be less productive. Next is the frequent machine setting. If equipment starts to wear over time without being maintained, the quality of the product being produced may be affected. Next is the variation of operation capabilities. This will refer to how much the level of demand changes over time due to external factors. Next is schedule charges. So this means the specific charge assigned to a permanent, partial, or permanent total. Next, second to the last is changing product priorities. Prioritization in the product management is a disciplined process of evaluating the relative importance of work, ideas, and requests to eliminate wasteful practices and deliver customer value in a quickest possible way given a variety of constraints. Last is the product modification. The product modification, this refers to a improvement of existing products by making necessary changes in the characteristic, nature, etc. of the product so that the changes in demand of consumers may be dealt with effectively. So in traditional manufacturing, the parts are made in batches, placed in inventory, and used whenever necessary. This approach is also known as the push system, which means that parts are produced in accordance with the order. Another definition of push system in inventory is push system are those where the business orders products with the aim of selling. In other words, the business pushes its existing stock on customer. So that means the rate at which the product come out at the end of the final assembly matches with the order quantity for the products. So when products and order matches the quality, it will improve the flow of production. There are no stockpiles within the production process. It is also called zero inventory stockless production and demand scheduling. Moreover, parts are inspected by workers as they are manufactured. This process of inspection takes a very short period, as a result of which workers can maintain continuous production, control immediately identifying defect, parts, and reducing process variation. This JIT system or just-in-time system ensures quality product. Extra work involved in stockpiles part is eliminated. So, just-in-time or JIT production, the manufacturing arranges for materials to arrive at production facilities just in time to enter manufacturing process. Thank you.
Sige na. Hello everyone, my name is Janice Dominguez and I will going to discuss the advantages of GIT and ISO 9000. So first, what is the advantages of GIT? First is the exact delivery schedule is possible with GIT practices. Second, quality of product is improved. Third is the lower defect rates or include lower inspection cost. Fourth is the lower raw materials inventory, in-process inventory, and finished product inventory resulting in lower product cost. Fifth is satisfying market demand without delay in delivery. Six is the flexibility in utilizing manpower as workers is trained to do as many jobs. 7 is the JIT helps in effective communication and reduce waste. And 8 is the less shop floor space is required. And the 9 is employee morale is high is an effective working environment. And the last is GIT reduces scrap and need for rework. Next page, please. The next is ISO 9000. ISO stands for International Organization for Standardization. It is an international body consisting of representatives from more than 90 countries. The national standard bodies of these countries are members of this organization. These are non-governmental organizations and can provide common standards of goods and services on international trades. ISO 9000 series has 5 number of international standards on quality management, which are listed below with the different objectives. First is the ISO 9000, provides guidelines on selection and use of quality management and quality assurance standards. ISO 9001 or 9001 is applicable for industries doing their own designs and development, production, installation, and service. It has 20 elements. Next is the ISO 9002 or 9002. It has 18 elements. It is the same as ISO 9001 without the first two tags include designs and development. ISO 9003, it has 12 elements covering final inspection and testing for laboratories and warehouses. Next is the ISO 9004, or this provides guidelines to interpret the quality management and quality assurance. It also the suggestion of which are not mandatory. Next page. The benefits of ISO 9000 series. First, this gives competitive advantage in the global market. Second, consistency in quality as iOS helps in detecting non-conforming early, which makes it possible to rectify. Third is the documentation of quality procedure adds clarity to quality system. Fourth, it is ensures educate and regular quality training for all members of the organization. Fifth, it is helping customers to have cost-effective purchase procedure. Next is the customers during purchase from firm holding ISO certificate need not spend much on its inspection and testing. This will be reduce quality costs and lead time. 7, this will aid to improve morale and development of workers. 8, the level of job satisfaction will be more. And the last, this will be help increasing productivity. Next. The steps in the ISO 9000 registration. Selection of appropriate standard from ISO 9001, 9002, 9003 using guidelines given in ISO 9000. Second is the preparation of quality manual to cover all the elements in the selected model. Third is the preparation of procedure and shop floor instruction which are used at the time of implementing the system. Also, to document these items. Fourth is the self-auditing to check compliance of the selected module. Fifth is the selection of registrar, an independent body with knowledge and experience to evaluate any one of the 3 quality systems, including ISO 9001, 9002, and 9003. And the application is to be submitted to obtain certificate for the selected quality system or model. Next. So this table is about the system requirement na naa sa ISO 9001 and ISO 9002. So both ISO 901 and 9002 has a management responsibility, quality system, product identification, and traceability. Next is the inspection status, inspection and testing, and inspection, measuring, and test equipment. Next is the control of non-conforming products. Next is the handling, storage, packaging, and delivery. The 9 is the document control, quality record, trainings, statistical technique, internal auditing, contract review, purchasing, process control, um, purchaser supplied product, and sa only ISO 001 has a corrective action, design control, and servicing. That's all. Thank you.
So my name is Rufami Salan. So to be continued, quality circle or QC. A quality circle may be defined as a small group of workers, 5 to 10, who do the same work voluntarily, meeting together regularly during their normal working time, usually under the leader of their own supervision to identify, analyze, and solve work related. This group present the solution to the management and wherever possible implements the solution themselves. The QC concept was first originated in Japan in 1960. The basic cycle of quality circle starts from the identification of the position. The, the philosophical basis of QC first is I believe that people will take pride and interest in their work if they get autonomy and take part in decision making. Second is it develops a sense of belongings in employees towards a particular organization. Third is a belief that each employee desire to participate in making the organization a better place. Fourth is it means method for the development of human resources through the process of training, work experience, and participation in problem solving. Next page, please. The fifth is a willingness to allow people to volunteer their time and effort for the improvement of the performance of the organization. Sixth is the importance of each member's role in meeting organizational goal. As you can see in the picture presented, this is the cycle of QC, the problem identification, problem selection, as per priority, problem analysis, generated different solutions, select best solution, prepare plan of action, present solution to management and implementation of solution. Next. The characteristic of quality circle. First is quality circle are small primary group of employees, worker whose lower limit is 3 and upper limit is 12. Second is membership involuntary. The interested employees in same area may come together to the form of quality circle. The third is each quality circle is led by an area supervisor. Fourth is the member meet regularly every week as per agreeable schedule. Fifth is the QC member are specially trained in the technique of analysis and problem solving in order to play their role efficiently. The sixth is the basic role of quality circle is to identify work related problems for improving quality and productivity. Next. The other characteristic of quality circle. QC enables the member of exercise their hidden talents, creative skills, and other. The eighth is it promotes the mutual development of their members through cooperation participation. Next, it gives job satisfaction because it identifying and solution challenging problems performing the job. While performing the job. The 10th is it provides their member with opportunities and receiving public recognition from the company's management. Next will be the member also receive recognition in the form of mementos, certificates, and privileges. Next is it also contributes to their self-esteem, self-confidence through acceptance of their recommendation by the management. Please, next page. The objective of quality circle. First is to improve the quality and productivity. Next is to reduce the cost of product service by waste reduction, effective utilization of resources, eliminating errors and defects. Third is to utilize the hidden creative intelligence of the employees. Fourth is to identify and solve work-related problems. Fifth is to motivate people of solving challenges tasks. Sixth is to improve communication within the organization. Seventh is to increase employees' loyalty and commitment to organizational goals. Eighth is to enrich human capability, confidence, moral, attitude, and relationship. The ninth is to pay respect to humanity and create a happy, bright workplace. The last is to satisfy the human needs of recognition and self-development. These are the characteristics and objectives of quality circle.
Hi, my name is Denzel Pauline C, and I'll be reporting about the Quality Circle, its philosophical basis of Quality Circle, and its characteristics. And I'm from the Precocity group. What is Quality Circle? A quality circle may be defined as small groups of workers who do the same work voluntarily meeting together regularly during their normal working time, usually under the leadership of their own supervisor, to identify, analyze, and solve work-related problems. This group presents the solution to the management and wherever possible implements the solution themselves. The quality circle concept was first originated in Japan in 1960. The basic cycle of a quality circle starts from the identification of the problem. So let's talk about its philosophical basis. First, a belief that people will take pride and interest in their work if they get autonomy and take part in decision making. It develops a sense of belongingness in the employees towards a particular organization. Third, a belief that each employee desires to participate in making the organization a better place. It is a means or method for the development of human resources through process. Fifth, a willingness to allow people to volunteer their time and effort for the improvement and the performance of the organization. And lastly, the importance of each member's role is meeting organizational goal. And that should be its major goal. It's the organization to meet its goal. And I'll be also discussing the characteristics of quality circle. So what are its characteristics? First, quality circles are small primary groups of employees or workers whose lower limit is 3 and upper limit is 12. Membership is voluntarily. The interested employees in some areas may come together to form a quality circle. Each quality circle is led by an area supervisor. The members meet regularly every week as per agreeable schedule. The quality circle members are specially trained in the technique of analysis and problem solving in order to play their role efficiently. The basic role of the quality circle is to identify work-related problems for improving quality productivity.